Welcome to AWS Mastery Labs, turning AWS chaos into clarity with bite-sized tutorials, hands-on labs, and exam-smashing tips. The AWS Certified Cloud Practitioner exam, currently referred to as CLF-C02, validates foundational, high-level understanding of AWS cloud, services, and terminology. In this video, we will be exploring 10 sample questions for this exam. The goal of this exercise is to review each question before exploring and eliminating incorrect answers, resulting in the correct answer being revealed. This is an essential technique for mastering AWS exam questions. Let's get started. Question: a company wants to migrate its on-premises relational databases to the AWS cloud. The company wants to use infrastructure as close to its current geographical location as possible. Which AWS service or resource should the company use to select its Amazon RDS deployment area? Let us identify and interpret key phrases in the question that will help with answering it. Migrate on-premises relational databases. This immediately tells us we're dealing with Amazon RDS or a similar managed relational database service, as close to its current geographical location as possible. This is crucial. It indicates the need to choose where in the AWS global infrastructure the workload should reside, primarily for reasons like latency, data sovereignty, or regulatory compliance. Option A, Amazon Connect Now. Amazon Connect is a powerful AWS service, but for a completely different use case. It's a cloud-based contact center platform that lets companies manage customer support and service operations via phone, chat, and other channels. There is no relevance to database hosting, migration, or choosing a geographical region. It doesn't help you deploy Amazon RDS or influence its location. Option B, AWS Wavelength. At first glance, this might seem tempting. AWS Wavelength does bring AWS compute and storage closer to end users, but it's targeted at mobile edge computing use cases, especially where ultra-low latency over 5G is required, such as gaming, video streaming, and real-time analytics. However, wavelength zones are not used for RDS deployment, and in fact, relational databases like RDS aren't even supported in those zones. Option D, AWS Direct Connect. This is a strong option if the question had asked about network performance. Direct Connect provides a dedicated private connection between your on-premises data center and AWS. It's ideal for low latency, high throughput scenarios, and secure data transfer. But it does not control or define where in the world your RDS instance is hosted. It's about the path to AWS, not the location within AWS. That brings us to the correct answer. Option C, AWS Regions. This is the right choice, and here's why. AWS is structured into regions, which are geographically isolated areas where AWS clusters its infrastructure. When you launch an RDS instance or any AWS service, you choose the region where it will reside. This allows you to deploy infrastructure close to your physical location, reducing latency and meeting local data residency requirements. For database migrations where geographic proximity is a concern, selecting the appropriate AWS region is key. That's exactly what this question is getting at. Which AWS service can identify when an Amazon EC2 instance was terminated? Let us identify and interpret key phrases in the question that will help with answering it. The phrase identify when tells us we're looking for a service that can record, track, or log events, something that offers historical insight into what actions were taken and when. We're not being asked how to prevent a termination or how to optimize usage. We're being asked how to know after the fact that an EC2 instance was terminated. That means this is about visibility and auditing, not operations or permissions. Option A, AWS Identity and Access Management, IAM. IAM is used to control who can do what in your AWS account, permissions, policies, and roles. It's essential for security and access control, but it doesn't tell you when actions are taken. There's no logging or event history in IAM. It won't show you when someone terminated an instance, only whether they were allowed to. Incorrect, because IAM governs access but doesn't record events. Option C, AWS Compute Optimizer. This is a service that analyzes your usage patterns and gives recommendations to improve cost and performance for EC2, Lambda, EBS, and more. But it's focused on resource efficiency, not event tracking. It doesn't monitor EC2 lifecycle events or tell you when resources were stopped or terminated. Incorrect, because it offers optimization advice, not activity logs. Option D, Amazon Event Bridge. Event Bridge is an event bus that can capture and route real-time events, including things like EC2 state changes. But here's the issue. It only works if you have predefined rules. If you didn't configure Event Bridge to catch a termination event before it happened, you won't find any record of it later. And crucially, it doesn't store historical logs. Incorrect, because while it can detect live events, it lacks retroactive tracking. Option B, AWS CloudTrail. CloudTrail is the auditing backbone of AWS. It records all API calls and management events across the AWS ecosystem. When an EC2 instance is terminated, regardless of how it's done, CloudTrail logs the event with a timestamp, user identity, and context. You can query it later to find exactly when and how it happened. This is the only service among the choices that is purpose-built to answer the question being asked. Correct, because CloudTrail provides complete historical visibility into EC2 termination events. A company has a test AWS environment. A company is planning on testing an application within AWS. The application testing can be interrupted and does not need to run continuously. Which Amazon EC2 purchasing option will meet these requirements most cost-effectively? Let us identify and interpret key phrases in the question that will help with answering it. First, the environment is for testing, not production. That usually means flexibility is acceptable. Next, the key phrase, the application testing can be interrupted and does not need to run continuously. That tells us this workload is fault-tolerant and interruptions are okay. This is critical because there's only one EC2 pricing model that offers steep discounts in exchange for allowing interruptions, and that's where we're headed. But let's reason through all the choices before landing there. Option A, on-demand instances. These are the most flexible EC2 instances. You pay by the second or the hour with no long-term commitments. They're perfect for unpredictable or short-term workloads where you need capacity instantly, like testing. However, while they're convenient, they're not the most cost-effective when compared to other purchasing options. If the app can be interrupted, there's a cheaper option out there. Incorrect, flexible, but not the lowest cost for interruptible workloads. Option B, dedicated instances. Dedicated instances run on hardware that is dedicated to a single customer. They are used when you have compliance or licensing requirements that prevent you from sharing hardware with others. But in this case, we're in a test environment where interruptions are fine. There's no mention of compliance constraints, and dedicated instances are significantly more expensive than the alternatives. Incorrect, because it is an overkill for this use case and not cost-effective. Option D, reserved instances. Reserved instances are all about long-term commitment. You reserve capacity for 1 or 3 years and get up to 72% discount compared to on-demand. But they're designed for steady-state workloads, apps that run 24/7. They don't suit workloads that can be interrupted or don't run continuously like test environments. Incorrect, because it is not a match for intermittent interruptible testing. Option C, spot instances. This is exactly what we're looking for. Spot instances let you use unused EC2 capacity for up to 90% less than on-demand pricing. The trade-off? AWS can reclaim the instance at any time with a 2-minute warning. That's practically the textbook definition of a spot workload. Non-critical, transient, cost-sensitive, perfect for spot pricing. Option C is correct, because spot instances are the most cost-effective option for this kind of test scenario. A company wants to monitor for misconfigured security groups that are allowing unrestricted access to specific ports. Which AWS service will meet this requirement? Let us identify and interpret key phrases in the question that will help with answering it. Misconfigured security groups that are allowing unrestricted access to specific ports. Right away, this question is flagging a common and serious security risk. Open ports accessible from anywhere. For example, a security group allowing inbound traffic on port 22 or 3389 from the internet is considered unrestricted access, and it's a frequent misconfiguration in cloud environments. So we're looking for a service that can detect risky security group configurations and alert or report on them automatically, ideally in near real time. This isn't about performance or health, it's about ongoing security monitoring for network-level exposure. Option B, Amazon CloudWatch. CloudWatch is designed for monitoring metrics, logs, and alarms. mostly around performance and operational health. You can use it to detect CPU spikes, memory usage, or set alarms based on thresholds. But it doesn't analyze security group rules, and it doesn't know whether a port is unrestricted or poses a threat. It simply observes what's happening, not what's configured insecurely. Incorrect, because it is great for telemetry, not for detecting security misconfigurations. Option D, AWS Health Dashboard. This service provides account-level alerts and information about AWS service outages, planned maintenance, or issues affecting your resources. It's valuable for visibility into AWS's infrastructure and its impact on your account, but it has no capability to evaluate your security group configurations. Incorrect, because it focuses on AWS service health, not security group monitoring. Option C, Amazon Guard Duty. Guard Duty is a powerful threat detection service. It uses machine learning and threat intelligence to identify suspicious activity in your AWS account, like compromised credentials, crypto mining, or unusual API usage. However, while Guard Duty can raise alarms if malicious traffic occurs, it doesn't audit security group configurations directly. It looks at behavior, not configuration state. Incorrect, because it focuses on threat behavior, not security misconfigurations. Option A, AWS Trusted Advisor. This is the correct answer. Trusted Advisor offers real-time recommendations to help you secure your environment and optimize performance and cost. Specifically, it includes checks for security groups with unrestricted access to certain ports, such as SSH, port 22, RDP 3389, or custom-defined ones. It scans your configuration and flags anything that violates best practices, like open ports accessible from the internet. This makes it ideal for the requirement at hand. Option A is correct because Trusted Advisor detects misconfigured security groups with overly permissive rules. Which AWS service or feature improves network performance by sending traffic through the AWS worldwide network infrastructure? Let us identify and interpret key phrases in the question that will help with answering it. Immediately, the phrase that jumps out is improves network performance by sending traffic through the AWS worldwide network infrastructure. This is a very specific clue. We're being asked to identify a service that leverages AWS's global backbone network to deliver faster, more reliable connectivity, especially across regions or from users to applications. It's not just about connectivity within a VPC or even across VPCs. It's about optimizing the path traffic takes over long distances, and that narrows our focus considerably. Option A, route table. This is a basic component within Amazon VPC. It determines how traffic is routed within the VPC, whether to subnets, gateways, or peering connections. But route tables are static configurations. They don't make intelligent decisions based on latency or performance, and they don't route traffic over AWS's global infrastructure. Incorrect, because route tables define network paths, but don't optimize performance across the global network. Option B, AWS Transit Gateway. Transit Gateway connects multiple VPCs and on-premises networks through a central hub. It simplifies large-scale network architecture by avoiding complex peering meshes. However, its job is aggregation and connectivity, not performance optimization. Transit Gateway doesn't route through AWS's edge locations or global infrastructure to speed up traffic. Incorrect, because it simplifies VPC to VPC networking, but doesn't improve network performance across the globe. Option D, Amazon VPC. The VPC is the fundamental building block of your AWS networking setup. It defines your virtual network, including subnets, routing, and security. But again, a VPC itself doesn't route traffic globally. It provides isolation and control over your networking resources, but no performance enhancements via the AWS global backbone. Incorrect, because it is foundational, but not a performance optimization feature. Option C, AWS Global Accelerator. Now we've arrived at the right answer. AWS Global Accelerator is designed specifically to enhance application performance and availability by routing traffic through the AWS Global Network infrastructure. Here's how it works. It assigns static anycast IP addresses and routes incoming internet traffic to the optimal AWS endpoint, based on health, geography, and performance. The magic lies in how it shifts traffic away from the unpredictable public internet and instead uses AWS's highly available, low-latency private backbone. This dramatically improves latency, throughput, and reliability, especially for global users accessing applications hosted in AWS. Option C is correct, because Global Accelerator is purpose-built to boost performance by using AWS's global infrastructure for intelligent traffic routing. How does AWS cloud computing help businesses reduce costs? We are asked to choose two best options. Let us identify and interpret key phrases in the question that will help with answering it. The focus is on how AWS reduces cost for businesses, so we need to look for answers that deal with cost efficiency, elasticity, and removal of infrastructure overhead. We're not being asked about feature sets or performance, just direct or indirect cost savings. That narrows the lens. Now let's break down each option. Option A. AWS charges the same prices for services in every AWS region. This statement is simply factually incorrect. AWS pricing varies by region based on infrastructure, operational costs, and local market conditions. For example, running EC2 in Northern Virginia, US East 1, is usually cheaper than in São Paulo, SA East 1. So this option isn't about cost savings, but rather a misunderstanding of pricing policy. Incorrect, because AWS does not charge the same across regions. Option C. AWS offers discounts for Amazon EC2 instances that remain idle for more than 1 week. This one sounds appealing, but is not true. In fact, AWS doesn't offer discounts for idle resources, quite the opposite. If you leave EC2 instances running but unused, you still pay for them. There are cost-saving options like spot instances or savings plans, but nothing that rewards leaving instances idle. So, this answer misrepresents how AWS billing works. Incorrect, because AWS encourages efficient use, not idle resources. Option D. AWS does not charge for data sent from the AWS cloud to the internet. This is also incorrect. In reality, data transfer out to the internet is chargeable and can be one of the more expensive parts of your AWS bill. The first GB per month might be free, but beyond that, charges apply. So this answer contradicts well-known billing behavior. Incorrect, because outbound data transfer is not free. Option B. AWS enables capacity to be adjusted on demand. This is a fundamental pillar of cloud cost efficiency. With AWS, you can scale resources up or down automatically in response to load. This prevents over-provisioning and means you only pay for what you actually use. It's a powerful lever for cost optimization. Option B is correct, because on-demand scaling reduces waste and aligns cost with actual demand. Option E. AWS eliminates many of the costs of building and maintaining on-premises data centers. With AWS, businesses no longer need to invest in physical servers, cooling, power, rack space, or redundant systems. There are no capital expenses, CapEx. It's all shifted to a pay-as-you-go model. This change in cost structure is one of the most compelling benefits of moving to the cloud. Option E is correct, because AWS removes upfront infrastructure costs. A company wants to establish a schedule for rotating database user credentials. Which AWS service will support this requirement with the least amount of operational overhead? Let us identify and interpret key phrases in the question that will help with answering it. The phrase, "establish a schedule for rotating," clearly points to a need for automated rotation of secrets. And with the least amount of operational overhead, tells us the company is looking to automate and avoid manual scripting, cron jobs, or third-party tooling. So we're looking for a native AWS service that not only stores credentials, but also automatically rotates them without heavy lifting. Option A, AWS Systems Manager. This service is great for operational tasks like patching, automation, configuration, and securely storing parameters using Parameter Store. However, Parameter Store doesn't natively support automatic credential rotation. You can store secrets there and rotate them with custom automation, but that requires scripting and maintenance, which adds to operational overhead. Incorrect, because it is useful for storage, but not built-in credential rotation with scheduling. Option C, AWS License Manager. License Manager is designed to help you manage software licenses for vendors like Microsoft, Oracle, or SAP. It lets you track usage and compliance of software licenses across EC2, on-premises servers, or hybrid environments. But it has nothing to do with database credentials or secret rotation. Incorrect, because it is completely unrelated to credential rotation. Option D, AWS Managed Services. This is a premium offering that helps large enterprises operate AWS infrastructure in a more hands-off fashion. It's essentially AWS operating your environment on your behalf, handling patching, backups, and incident response. While it may provide support for security best practices, it's not a standalone service for secret rotation, and it's not designed to solve this problem specifically. Incorrect, because it is overly broad, not purpose-built for credential management. Option B, AWS Secrets Manager. This is the clear winner. AWS Secrets Manager is purpose-built for storing, retrieving, and automatically rotating secrets, including database credentials, API keys, and other sensitive information. It comes with native support for credential rotation using Lambda-backed rotation functions, with predefined templates for RDS, Redshift, and other managed databases. You can schedule automatic rotation, define custom rotation intervals, and integrate with IAM for fine-grained access. This eliminates the need to build and maintain your own rotation logic, dramatically reducing operational overhead. Option B is correct, because Secrets Manager delivers automated credential rotation with minimal effort exactly as required. A company has a set of e-commerce applications. The applications need to be able to send messages to each other. Which AWS service meets this requirement? Let us identify and interpret key phrases in the question that will help with answering it. The key phrase here is send messages to each other. That immediately indicates asynchronous communication, often handled through messaging systems or queues. This is a classic pattern in microservices architecture, where applications need to decouple from one another, enabling them to operate independently, recover from failure, and scale seamlessly. We're not looking to load balance, auto-scale, or process real-time analytics. We're simply looking to pass reliable messages between applications. Option A, AWS Autoscaling. Autoscaling is designed to dynamically adjust the number of compute resources, like EC2 instances or containers, based on demand. It helps reduce costs and maintain performance. But it has nothing to do with inter-application communication. It won't help your apps send or receive messages. Incorrect, because it is focused on scaling compute resources, not message passing. Option B, Elastic Load Balancing, ELB. ELB is useful for distributing incoming traffic across multiple backend targets, such as EC2 instances, containers, or IPs. It helps with availability and fault tolerance, but it's used for handling real-time synchronous requests like HTTP or TCP traffic. It does not support asynchronous communication between applications or message queuing. Incorrect, because it is great for synchronous traffic, but not for application-level messaging. Option D, Amazon Kinesis Data Streams. Kinesis is a managed service designed for real-time streaming of large volumes of data for use cases like analytics, telemetry, or log processing. While technically it enables one system to send data to another, it is optimized for high-throughput, real-time data ingestion, not for simple decoupled messaging between services. Incorrect, because it is powerful for streaming data analytics, but overkill and unsuitable for standard message passing. Option C, Amazon Simple Queue Service, Amazon SQS. This is the ideal answer. SQS is a fully managed message queuing service that enables asynchronous communication between distributed systems. Each application can send messages to an SQS queue, and other applications can consume them at their own pace. This decouples the services, improves fault tolerance, and handles temporary load spikes gracefully. SQS also supports message durability, retries, visibility timeouts, and dead letter queues, making it reliable and production-ready for e-commerce apps that must exchange transactional or workflow messages. Option C is correct, because SQS is designed for exactly this, sending messages between applications in a decoupled, scalable way. Which AWS service is a key-value database that provides sub-millisecond latency on a large scale? Let us identify and interpret key phrases in the question that will help with answering it. The most important keywords to focus on are key-value database. This narrows it to the databases optimized for simple lookups using a key. Sub-millisecond latency. This demands extremely fast performance, often required in high-throughput real-time applications. Large scale. The service should scale horizontally to support massive workloads. Option B, Amazon Aurora. Aurora is a high-performance, fully managed relational database engine compatible with MySQL and PostgreSQL. It's designed for structured, SQL-based workloads, not key-value access patterns. While it offers impressive performance and scalability, it does not deliver sub-millisecond latency in most scenarios, especially compared to a true key-value store. Incorrect, because it is a relational model, not a key-value store, not optimized for sub-millisecond latency. Option C, Amazon Document DB with MongoDB compatibility. Document DB is designed for document-based, JSON-like workloads, and is a fully managed service compatible with MongoDB. While it supports flexible schemas and nested data, it is not a key-value database, and it doesn't consistently offer sub-millisecond latency for operations. This is more appropriate for semi-structured, hierarchical data, not high-speed key-value access. Incorrect, because it is a document store, not key-value, slower latency profile. Option D, Amazon Neptune. Neptune is a purpose-built graph database optimized for handling highly connected data using graph models like Property Graph and RDF. While powerful in its domain, such as social networks or fraud detection, Neptune is not key-value, and it's not optimized for sub-millisecond response times in general key-based lookups. Incorrect, because it is a graph database, unsuitable for key-value workloads or high-throughput simple lookups. Option A, Amazon DynamoDB. This is the correct answer. DynamoDB is AWS's fully managed NoSQL key-value and document database, designed for single-digit millisecond and sub-millisecond latency at scale. It supports massive workloads with built-in horizontal scaling, automatic replication, and millions of requests per second. With features like DynamoDB Accelerator for in-memory caching and on-demand capacity, it serves use cases like gaming, e-commerce carts, IoT, and more. Option A is correct, because DynamoDB is purpose-built for high-throughput, low-latency key-value access at global scale. Which option is a benefit of the economies of scale based on the advantages of cloud computing? Let us identify and interpret key phrases in the question that will help with answering it. This question asks about one of the fundamental financial advantages of cloud computing, specifically, economies of scale. This term refers to cost advantages that result when services are provided at larger volumes. The cloud allows providers like AWS to spread the cost of infrastructure across thousands or millions of customers, driving down the per-unit cost. So we're looking for the option that best reflects how the cloud reduces costs as usage increases, and how those savings are passed on to the customer. Option A, the ability to trade variable expense for fixed expense. This is actually backwards. One of the cloud's advantages is trading fixed capital expense, like buying servers upfront, for variable operational expense, paying only for what you use. Cloud lets you avoid large upfront costs, which makes it more flexible and cost-effective, especially for startups or unpredictable workloads. Incorrect, because the benefit is trading fixed for variable, not the other way around. Option B, increased speed and agility. While this is a real benefit of cloud computing, such as launching new services quickly, spinning up instances in minutes, and deploying globally, it's not tied to economies of scale. Speed and agility are operational advantages, not cost-saving mechanisms derived from massive scale. Incorrect, because it is a valid cloud benefit, but unrelated to economies of scale. Option D, increased operational costs across data centers. This goes directly against the advantages of cloud computing. Cloud providers aim to reduce operational costs by consolidating workloads, automating management, and optimizing hardware usage. Suggesting increased costs contradicts the premise of cost efficiency at scale. Incorrect, because this is a disadvantage, not a benefit, and it contradicts cloud principles. Option C, lower variable costs over fixed costs. This is the right answer and perfectly captures the essence of economies of scale in the cloud. Because AWS operates at massive global scale, it can negotiate better hardware prices, optimize data center operations, and build infrastructure more efficiently than individual companies. These savings are passed on to customers in the form of lower variable costs, meaning you pay less per unit of compute, storage, or bandwidth as usage grows. Option C is correct, because this reflects true economies of scale. More usage equals lower per unit cost, which is a major financial benefit of cloud computing. Thank you for joining us in this video. If you haven't already, we'd love for you to subscribe to our channel to stay updated with our latest content. We look forward to sharing more insights with you in another video. Until then, keep exploring. And thank you for watching.